Hey guys! In our last video, we discussed RCE vulnerabilities, what they are, what they can do, and some real-life implications of them. In today's video, we'll continue to dive deeper into the technical details and have a look at a real-life example of remote command execution. The remote command execution vulnerability that we are going to look at is a vulnerability that was found and reported to SSD in 2018. This vulnerability was found in phpCollab version 2.7.2 and prior. Now, phpCollab is an internet-enabled project management and collaboration system. Similar to the vulnerability in last week's video, this one also occurs due to unsanitized user input, only this time it is done through a file upload feature. The vulnerability is executed on a page that administrators use to add new clients, editclient.php. This page lacks basic tests for whether or not a user is logged on when the system is accessed directly and a post request is used. Attackers can exploit this flaw to upload a file on this page that contains a line of code that could be executed inside phpCollab without requiring to be logged on to the phpCollab application. Now let's have a look at how to execute this remote code execution. The first thing we need to do here is abuse the upload functionality and upload some code to be executed. We know that the backend runs PHP, and thus we will use some PHP code to inject into a file. Our payload opens up the PHP tag to signal that what is found in between them is PHP code. We then supply a system statement, and this function is going to take a string given as an argument and execute it as a system command. Now, what string are we going to give it? Well, we're going to tell it to take the cmd get parameter. That way we can decide what is being executed dynamically. Now we can send our post request to the vulnerable editclient.php endpoint and our file has been created. But our code hasn't executed yet. We first of all need to find our file, and all of these files are stored in the logos client directory, but their name is chosen by the application, so we need to figure out the exact name of our file. Luckily, the server just uses a numeric ID as the file name, which is incremented every file upload, thus we can just check 1.php, 2.php, 3.php, and so on until we find it, and in this case it was found at 43.php. All that's left for us to do is to browse to that endpoint and supply the cmd get parameter with, for example, who am I as the value, and that gives us our command execution. You can have a look at this vulnerability on the advisory page found in the description, but that is it for the Lil Bits series. We hope this series helped you learn more about the world of cybersecurity and develop the skills you need to succeed in the industry. If you're looking for more information, you can find the advisories on the site in the description and have a look at the other series on this channel to learn more about the world of cybersecurity. Thanks for tuning in. We hope to see you implement what you've learned here and help our ecosystem stay safe. Take care, everyone.